This video is on oxidation numbers or states. I'm just going to run through what they are, any rules and exceptions that you'll need to learn, and examples of how to determine oxidation states in molecules, ions and reactions. Okay, so what are oxidation numbers? Well, oxidation numbers tell us what is being oxidized and what is being reduced in redox reactions. The oxidation number or state of an atom is equal to the total number of electrons that have been removed from an element to give a positive oxidation state, or added to an element to give a negative oxidation state to reach its present state. This will make more sense when I go through the examples at the end. So oxidation involves an increase in the oxidation state, and reduction involves a decrease in the oxidation state. The oxidation states of elements change during a reaction, and that allows us to determine whether it's been oxidized or reduced without having to use half equations. Okay, there are just some rules that you'll need to learn for oxidation states. So firstly, the oxidation state of all uncombined elements is 0. It doesn't matter what the element is. The sum of the oxidation states of all atoms or ions in a neutral compound is 0. The sum of the oxidation states of all atoms in an ion is equal to the overall charge on the ion. There are some elements that almost always have the same oxidation states in their compounds, so I've just summarised these in a table. So if we have group 1 metals, the oxidation state is always +1. Group 2 metals, it's always +2. For oxygen, it's usually -2, except in peroxides where it's -1, and OF2 where it's +2. For hydrogen, it's usually +1, except when it's bonded to a metal, when it'll be -1, and for fluorine is always -1. Okay, so if we just go through some examples on how to determine oxidation states of atoms in molecules. So let's say we want to work out the oxidation state of chlorine in these examples. So firstly, we know that the oxidation state of hydrogen is +1. We want to work out what the oxidation state of chlorine is, and we know that the oxidation state of oxygen is -2, and there were 4 of them. So +1 -8 equals 0, because the sum of all the oxidation states are equal to 0. So +1 -8 is equal to 0, so the oxidation state of chlorine must equal to +7. Second example, so we know that the oxidation state of oxygen is -2, and there are 2 of them, so that gives 2 times -2 is -4, plus the oxidation state of chlorine to give 0, so the oxidation state of chlorine must be +4. Last example, we know that the oxidation state of carbon is +4, and here we have 4 times the oxidation states of chlorine is equal to 0, so the oxidation state of chlorine here must be -1. Okay, in ions then, if we want to work out the oxidation state of iron in this ion complex, we know that the oxidation state of chlorine is -1, and there are 6 of them. So the oxidation state of iron plus 6 times -1 is equal to -3, which is the overall charge on the iron. So the oxidation state of iron in this case must be +3. Next example, if we want to work out the oxidation state of aluminium in this aluminium complex, so we know that the oxidation states of molecules as a whole is 0, so the water molecule. The sum of the oxidation states of the hydrogens plus the oxygen is equal to 0, so we can ignore that in our calculation. And then for the OH, we know that the oxidation state of oxygen is -2 and of hydrogen is +1. So the OH has an overall oxidation state of -1, and there are 5 of those. So the oxidation state of aluminium plus 5 times -1 is equal to -2, which is the overall charge on the ion. So the oxidation state of aluminium must be +3. Okay, so in reactions we can use the change in oxidation states to determine whether oxidation or reduction has occurred or neither. So the first example, if we have silver ions plus chloride ions going to silver chloride, the oxidation states in the reactants and the product are the same. So there's been no change in the oxidation states for both elements, and so neither oxidation nor reduction has occurred. In the second example, if we want to work out whether the zinc has been oxidized or reduced, it starts off with an oxidation state of 0 and it ends up with an oxidation state of +2. So the oxidation state of the zinc has gone up, and so it's been oxidized. And we also know it's been oxidized because it's lost 2 electrons. So if you remember from an earlier video, oxidation is also the loss of electrons. Last example, for copper, it starts off with an oxidation state of +2 and then it ends with an oxidation state of 0. So in this case the oxidation state of copper has gone down, and so reduction has occurred. And so we also know it's reduction because the copper 2+ has gained 2 electrons.